Welcome to the Software Process and Measurement Cast number 676. I'm Tom Cagley, your host. Today, we speak to Kit Merker, COO of Nobl9, about service level objectives, SLOs. Kit provides down-to-earth advice for adopting and using SLOs to benefit teams and organizations. We even talked about how some organizations weaponize SLOs and how to help make that not happen. Kit's bio. Kit Merker's 20-plus year career spans product management, engineering, evangelism, and community building roles at Google, Microsoft, JFrog, and governing boards of the Cloud Native Computing Foundation, CNCF. He is currently Chief Operating Officer for Nobl9, driving community and growth for service reliability for enterprise development teams. Are you ready to talk SLOs? It's time for the interview. Kit Merker, welcome to the Software Process and Measurement Cast.
Hey, Tom. Great to see you. Thanks for having me.
I am really excited. Let's start with something pretty basic, maybe real easy. What's an SLO?
What is an SLO? Well, it stands for service level objective. And the way I like to think about it is as a goal. An SLO is a target or a goal for how a service should work. And I think that the kind of easy way to think about it is it's the proportion of events or time that should work versus not work. And the intriguing thing about it for me is if you can define what a service should do, you can engineer or design a service. You can design a system to deliver to that service. It's like if that service could be as simple as cutting hair or, making a cocktail at a restaurant, or it could be delivering a website. Anything in principle could be measured as a service level. So what percentage of the time does it work and not work? And at what point is it acceptable? And really that SLO concept is about defining expectations and actually excellence, and recognizing that it's, not perfection. This is really what an SLO is all about. So, we could go deeper on that, but this is sort of the high level concept is I want to give you a service. I can't make it perfect. I'm sorry. So we set a goal that is slightly less than perfect, but still satisfies what you need most of the time. And I come up with a strategy for how I'm going to deal with that gap, the what's referred to as the error budget, or the gap between the SLO and 100%.
It should be like 5 nines, right? Let's make it, everything should be 5 nines.
Well, it's sort of wishful thinking. The thing is that the nines are exponential, and it's kind of hard to realize this, but every 9 that you add is actually exponentially harder than the previous 9. It sounds like you're just throwing out, 3, 4, maybe 5 nines. But the reality is that what you're doing is you're cutting into an order of magnitude. And to make it very clear, 99 is 1 out of 100. 99.9 is 1 out of 1,000, right? 99.99 is 1 out of 10,000. So very quickly, you realize your error rate, right? It gets very small. And on a time basis, in a year, 5 nines is only 5.5 minutes per year of time that you'd be willing to be down, which, maybe sounds good, but it's not very realistic. It's very expensive. I think the interesting thing about it is that not all parts of a service are the same. So if you think about, let's say you're running a retail website, right? You got a catalog where people can go browse around, look for shoes, look for books, whatever it is that they're trying to do. And then you have a checkout process, right? The checkout where real money is changing hands. And if you think about that as one pile of events, right? You got this big data set of events of people clicking around on the catalog and then eventually clicking on the checkout. You say that needs to be 5 nines. Unfortunately, you won't know if your checkout works because you have a very high volume of low value events and you have a very low volume of high value events. And by putting those all into one data set, you're going to be hiding the checkouts, right? You may have less than 1 nine's worth or 5 nines worth of events. So think 0.0001% of those clicks might actually represent real money. So in the SLO methodology, what you would do is you divide it. You'd say, we're going to separate the catalog where, I can live with a lower set of reliability. First of all. Second, I don't want it polluting my checkout numbers. Separate into 2 things and set 2 different goals. focus my engineering effort on making sure that that checkout works, right? And it has the proper retry and proper reliability, performance, et cetera, because it's where real money's changing hands. And on the catalog, maybe you can, lower your goal quite a bit, maybe even, 2.5 nines, because that catalog experience is just not as value, and the volume's higher and user expectations are different. And this is a really powerful idea, counterintuitive, I think, that by separating and having more fine-grained goals, you can lower the reliability goals in some areas and reinvest that energy into making the areas that truly matter to the business and to customers, make them work at a much higher level.
So that sounds difficult, sorting those two things out. And obviously, we all work in political worlds, right? And I'm not saying politics, but, if I'm the person who's in charge of the catalog portion of the website, of course, everything's important. And I would argue that my stuff is just as important as the person who's in charge of, and hopefully it isn't segregated like that, but the person that's in charge of, taking the money and getting it somewhere. How do you sort that out? And how do you get an organization to actually see what is more important?
Well, it's a great point. And you don't want to diminish the value of the software working. But what I would kind of, argue is, well, show me the evidence and data of the change in user behavior, right? This is really what I would look at is, can you demonstrate through data that the service running at 2 nines or 3 nines actually correlates to a drop off in purchases? And if that's the case, then I buy your argument, right? I actually do buy that there is a breaking point. The question is, how do you define that breaking point and understand it from an objective point of view of the customer and the business? So one of the ways that this is done is, you take an outage that actually happened and you see that during that time, you look for indicators, objective real world indicators that there was an impact on customers and business. Maybe people started complaining more on social media. Maybe you saw a rise in support tickets, shopping cart abandons, et cetera, that happened during that outage to that service. And because of that, you now have found, interesting information about your hypothesis that your service needs to have that higher level of reliability, right? And the other way I would look at this is you can experiment with different data sets within that. You can say, hey, look, when we see these different regions which are having a worse experience, we see that, where maybe they have worse connectivity, et cetera, maybe you're seeing that correlation there. So we look for these kinds of correlations and we do a feedback loop. We try to make it so that we improve over time. There is no right answer forever on these services because you're constantly changing them. So the question is, how do you build a process by which you reevaluate these assumptions and make them more nuanced so that the three main stakeholders, I think of the three stakeholders of these services as the customer, the engineer, and the business. Okay. Those three stakeholders together want the service to operate in a certain way. How do you make sure that there's a feedback loop that tunes the service? If you go too far to make it too reliable, right? The pain is felt in the business in terms of cost. You need more headcount, you need more cloud infrastructure. You release more slowly. The pain on the engineers is that they have to be more sensitive to on-call, which we all love being on-call. But if you raise a 5 nines on-call, it's very different than being on a 2 nines on-call. Very different experience. So that's the pain on the engineer. So finding the right balance is important for everybody, to be honest. And if you want to deliver features and get that out the door and create more value in terms of, meaningful work for engineers, so they don't hate their job, right? They want to work on new and interesting problems. Then having a strong, kind of process in place that uses data to make these decisions versus kind of what you were describing, which is negotiating, right? I have my fiefdom, I have my area. It must be perfect. If it's not, that's your fault. And on-call is your punishment, right? Instead of doing that, right, what we want to do is we want to build a better decision-making process. And by having better decisions, it leads to better software. It leads to better culture. It leads to fulfillment and a meaningful growth in these businesses. And what the cool part, it also makes business sense because now you can focus on what matters to customers and everybody gets bought in. Because at the end of the day, you want to build features to attract customers. You defer a lot of the work through technical debt. The engineers issue technical debt to the business so that they can ship early. And at some point, that technical debt comes back and the payment comes due, right? And so now we want to insert that into our planning process so we don't get over leveraged, if you will, because at some point we're going to hopefully attract more customers. More customers means more stress on the system. which means we now need to pay attention to reliability, maintainability, et cetera. And that's really the whole idea here of SLOs is both from an operational perspective, does the system work the way it's anticipated to work? And from a technical debt perspective, are we maintaining a good balance of fixing technical debt that's actually customer impacting or business impacting or engineer impacting? Or are we just have technical debt that we can't tell the difference between? This to me is really the driver of that cultural change, that adoption is getting people to understand it's in their best interests to not make unverifiable assumptions about what matters to customers and to treat it more as a hypothesis-driven, data-driven approach, which is hard. I agree with you. It's hard. But that is the kind of the goal of what SLOs are really about. This is the essence of what this kind of process is trying to do.
Sounds great. Sounds really hard. What do? You have to employ, half a dozen, PhD mathematicians and statisticians to make this happen, and all with their calculators and slide rules.
Math is hard. And we've worked with a lot of people. There's actually a great talk, and I'll give a little plug for SLOConf, which is a conference that I'm involved with that is all about SLOs. And there's a great talk from Steve McGee from Google. It's called SLO Math. Now, the funny little story about this talk is we had a track called Deep Technical, okay? And so this talk, this Steve McGee, SLO Math was intended to be a deep technical talk. Well, through some series of mistakes, it ended up in the SLO 101 track, the new to SLOs track. Okay. So we took our most technical talk from one of the most senior, mathematician geeks out there, and it ended up in the newbie track. And what a happy mistake, by the way, because it became such a popular talk. People got to go deep on the math and the ideas behind SLOs as part of their introductory course. And the feedback has been just amazing with that. I definitely recommend if you're interested in the math piece to go there. But there is a lot of math involved in this because it's not, I'll share one kind of counterintuitive idea about it. Can you build reliable things from unreliable things, right? There's this sort of, if you kind of squint at it, layman's theory of it, you go, okay, well, if my service is going to run at 3 nines, that means that the cloud under it needs to run at 4 nines, which means that the data centers need to run at 5 nines, which is actually completely backwards. It's actually the other way around. We can build reliable things from unreliable things if we can anticipate the failure and model the failure. An example that might be familiar, if you're familiar with RAID arrays in hard drives, right? Well, hard drives, we know that they're not infallible. We don't try to build better hard drives, right? I mean, obviously better hard drives, better failure rates is good, but the idea is you're building an array. You have multiple hard drives, and if 1 or 2 of those fail, the data is not lost, right? This is building something that's more reliable from components that are less reliable. And modern cloud architecture is based on the same principle, right? Why do we geo-distribute our data centers? Why do we have multiple instances running? Why do we have containers? Why do we have VMs? All of this is to have redundancy and to have it automatically adapt to the fact that the underlying system is less reliable. So when we're building and thinking about SLOs, we're trying to build high reliability systems. What we really have to do is be able to create that redundant, resilient system that can use less reliable components to make something that's actually more reliable in aggregate. And that is the interesting thing. And if you want to know how it works and the math behind it, go watch Steve's talk because I don't understand it. But that is the concept behind it that drives this whole ability to even achieve high levels of nines, right? That's the whole concept.
It sounds like something that you would have to instantaneously build in to begin with, right? You'd have to architect the systems and all of the hardware architecture to actually do this. Is this something that people who live in less perfect worlds, the big organizations that have systems that just exist, work with a team that has 300 systems they're supporting? They don't know some of what they are. How do they get in on this sort of a thought process?
Well, it's a very good point because I think there's a misnomer about reliability engineering being about modern cloud native, architecture and building things that are incredibly, scalable and reliable. And to be clear, like a lot of the reliability engineering, I'd say curriculum and theory has been developed out of these large scale, internet scale kinds of systems. But I've been working with people from large banks and other kinds of institutions that have been around for a long time. And we're even talking about SLOs for mainframes and things like that, which sounds crazy, but if you think about it, it really comes down to setting the right expectation. So if you have a certain level of service, it can be much, much lower than, what you think of as nines, right? It's not just about 99.9%. It's about modeling the expectations of a service. If that service only works, 50% of the time, I'd rather have that modeled into my learning system so that I'm not surprised when I'm expecting it to work 5 nines and the system only works, 1 5. I don't want to be, constantly slacked and alerted that, hey, guess what? The system isn't working at 5 nines. It's like, yeah, no kidding. I know it doesn't work at 5 nines. That's kind of the point. But if it slips below that and it stops working even half the time, maybe I would like to know about that, right? So the first thing is about defining clear expectations. And if no one ever wrote down that this service, or even measured if this service, how often it works and what the pattern is for it's working, then you have less information to make good decisions about. And then some person in your organization might have a wrong expectation. They say, like, this is one I hear about all the time. They took a dependency on an unreliable service. And that's okay if you know what the expectations are. And this leads to good conversations between teams. Team 1 goes to team 2. I see that you've got this thing. I need to get data out of it. Here's my load pattern. What's going to look like. Is that going to work for you? Okay. Why is that happening in meetings? Like, if the teams can all publish their SLOs, the historical data, et cetera, then you can start to understand dependency risk. You can start to understand engineering decisions about retry logic, caching strategies, geo-distribution of data, and you can start to make the system better, or at least understandable for the engineers who are trying to piece this thing together. If you don't do that, then you're basing it on assumptions. And that assumption-based model is really challenging. And then you can also think about SLOs for third-party services, which I think is a really interesting idea as well. You have a dependency on the internet and other services. More and more we're seeing service-based architectures using SaaS services and infrastructure as a service together, composed into an application. So how do you know if, your cloud provider, your identity provider, your database is down? Well, you should set an SLO on it. You should understand what the objective is or what your expectation is of that service and monitor it externally. So you can see if the issue you're facing is your fault or the service's fault. You can provide feedback, et cetera. And if those services all kind of, start to publish their SLOs, then we start to have more data that we can use to make engineering decisions. So it's not just for, well, I'll add one more point about the modern versus older. It's great for a transition. It's great for a transition. And I talked to a lot of teams about this. Hey, we want to move to Kubernetes. We want to move to cloud. We want to do this. And we have this older system. And the question's like, okay, you're going to go do all this work. Is it going to be better, the same, or worse? And if you're going to be running in some sort of mixed mode, right? You're running in 2 different environments at the same time. How do you compare them? If you can define the expectations of the service today and then start to build that change and then measure it after the fact, a lot of cool things happen, right? One is you have a way of understanding if you're moving in the right direction. You have a way of running in mixed mode, and you also have a way of explaining the benefit, because the benefit to the business may be in terms of efficiency. It may be in terms of cost. It may be in terms of just being able to take on more customers. But I talk to a lot of business people, in fact, CFOs and others, who go, yeah, I just spent X million dollars, on a digital transformation, DevOps transformation project, and I have no idea, what we got out of it. Customers still seem to be complaining about the same rate they were before. So what do we buy, right? And that to me is, I think, an important question too. And the engineering team isn't even sure about that, right? That can be a challenge. So I recommend doing SLOs first as part of a transition to a modern thing, not wait until the service is good and then set SLOs. Because having information about where you are today is really useful for prioritizing technical debt, which is what we're talking about here, really re-architecting and bringing these systems to do better things to prepare you for more feature delivery. That's really, to me, is the key idea behind that tool. It's not just to say, oh yeah, the system works super well. That's not really interesting. It's more about how do we make good engineering decisions to make the system work appropriately for the different stakeholders.
I always worry when we get to these sorts of ideas that make sense, they're data related, that organizations have a propensity to weaponize them, to screw them up. How is that possible in this scenario?
Yeah, weaponized SLOs. As actually, it could be a very cool much longer talk. I might have to do that. So yeah, so where I see SLOs become weaponized, one is when they're set too high. And when they're set too high for the service and there's no grounding in reality, because somebody has, I won't call it a 9 fetish, but they kind of have a, we want to have more 9s because I want to have more 9s. It's 9s for 9's sake. Okay. That is one place where I think, it gets a challenge. And that, by the way, might be 100% too. Like I've heard that kind of attitude before, especially, from kind of non-technical leadership. And they actually think they're being inspiring. They say, you know what? We need it to be 100% reliable, 200% secure, and 300% more features than anybody else. Okay. And that's how in fact, I see a lot of misguided discussions about reliability. Oh, we got to inspire reliability culture. I just talked to somebody about this. They said, my CTO says that reliability is our number one feature. And he said, but behind the scenes, everybody says, well, and more important than your family. And that's a big challenge. So what happens when an engineer hears?
And those people are now part of the Great Resignation, right?
Absolutely. And I would love to talk about the Great Resignation. It's an amazing thing because this is the disconnect. The disconnect is by saying I want higher reliability, it leads to the engineers rolling their eyes and they decide on your behalf. I talked to a very senior SRE, ex-Google guy at a freshly IPO'd company, and he told me that he doesn't trust the business people and the PMs to come up with SLOs. He doesn't trust them. He says you got to have senior engineers because they're the only ones that can really translate and have the attention span to translate the SLOs, the business requirements into SLOs and understand the impacts because of exactly this reason. You don't get clear answers driven in data. You get wishes and assumptions and inspiration, which does not lead to good engineering. And this is the disconnect. So on this Great Resignation topic, specifically for engineers, I've seen some really interesting conversations. I tweeted recently and kind of hit a nerve and it got me really into this topic. So I said, the saying, people don't quit companies, they quit managers. So I said, people don't quit managers, they quit on-call rotations. And, people seem to agree with me. Okay, let's put it that way. And I got a lot of people reaching out. I've been thinking and researching this topic a lot more since that. And some of the things and patterns that I'm hearing from a lot of folks is it's not on-call per se that bothers them. They don't mind being on call. The problem they have is they're on call. They wake up at 3 a.m, fix an issue. They go to the postmortem or retrospective the next day. They come up with an action plan for how to recover from it. And then what? Back to the grind. Too many features, too much other work. We never fix it. And then it happens again and again and again and again, right? This is the pain.
It's been around for a while. That isn't just now. That's been forever.
So what's changed? Okay. I think a couple things have changed. One is engineering is in high demand for many reasons. COVID gave us digital transformation in an accelerated pace. The demand on engineers, both from a software development perspective, but also from a reliability engineering operational perspective. You talk to some of these guys at like food delivery companies, for example. They're essential services for the world. Men and women that I talk to are all trying to keep the services running as best they can because they know how important it is for the world. This was not the case, 3 years ago, right? Okay. So we had little time to actually catch up on the technical debt. They're brute forcing their way through it and they know it. Then you go to the next step on this and you go, okay, so engineers are super critical. They're working super hard to keep everything working. And they're in high demand. Then you have the problem of the difference in the work. Okay. So perks. It used to be you go in, you get a great office, cool building. You got to hang out with your friends. You get food, massages, haircuts, all this stuff. Well, those perks are no longer really differentiating in the way that people used to treat them. Now it's about the meaningfulness of the work. So I saw this McKinsey study that's really interesting that talks about what they call the great disconnect. Okay. And the great disconnect idea is that the managers, the management of the company overestimates compensation and work-life balance and a few other factors. Those are the ones that stood out to me. They overestimate those factors and they underestimate two things: the meaningfulness of the work and the relationship of the people. And the thing I think has come here is that the on-call work is not meaningful. The on-call work is not meaningful. The post-mortem action items that don't get fixed, the technical debt that keeps bugging you that you're never allowed to take care of, that you can never catch up with because you can't say no to the feature development and the drive. It hurts the meaning and it hurts the relationship. It creates a cognitive dissonance in the organization between those stakeholders. And when you're in that situation and you have the option to work from anywhere for anyone, and it's, you're going to work from home. So, it's the same laptop, it's the different Slack space, it's the same exact world, you just switch your t-shirt. It becomes a lot easier for you to say, what am I doing here? Right. And what I've found, and this is the shocking thing to me, is the engineers that I'm talking to are foregoing more money in favor of teams that have a very clear reliability engineering strategy. This is, to me, is the most interesting part of it. And I have now talked to many senior engineers, especially that have reliability mindsets, where they're going, look, I was trying to change the culture from the inside. I was trying to break the cycle of on-call and technical debt and bring in SLOs and bring in, better monitoring observability, bring in better incident response strategies. I couldn't get it to happen. People weren't listening to me. So I made sure that my next hiring manager had it on their list. And in fact, I made sure that I talked to people about their on-call. I made sure I talked to people about how they deal with putting features on hold to fix technical debt. And that's how I made my decision. And that, to me, is powerful. That's a powerful situation we find ourselves in. And I think, it hopefully is a wake-up call to engineering leadership and business leadership that they need to understand this problem. Because I think they do recognize engineering talent is critical to success. Businesses that saw themselves as, there's the business side and there's the technical side. Now it's a digital business. So we did digital transformation. The question's like, well, how do we run a digital business? And I think this is where we are now. And I think this is where it becomes really interesting which companies are going to win and which companies are going to lose in this fight for talent.
I think we could go on for a while.
Yeah.
Kit, if you woke up tomorrow morning, someone handed you a magic wand, cup of coffee, or your caffeinated beverage of choice and said you had 2 wishes to make the world use SLOs safely, better, to make the world a better place, what would those 2 wishes be and why?
It's kind of funny to get 2 wishes. I was thinking you just give me 1. But I think the first wish that I have is that people could be realistic about what they can accomplish and understand that there are trade-offs, and that this whole thing comes down to understanding the trade-offs, and you can't have it all. And I think this is the number one thing that I think people delude themselves about, is think, I'm going to hope for the best and I'm going to build it, we're going to run as fast as we can and we'll just deal with the outages as they come. And there is a place for that in early business. But once you get past a certain level of scale, the trade-offs are all that matters. And paying attention to those trade-offs and having honest, frank conversations about what trade-offs are we really managing, that's the number one. And I think that's the wake-up call that I think a lot of people need to see. So that'd be my first, suddenly everybody realizes oh my gosh, there's trade-offs. I can't have 100% reliability and I can't have this and I can't have that. I got to think about how I make this whole system work. And the second one is, I would say, I wish that people would lose the fear that it's too complicated and I can't get started, because actually there's so many practitioners building SLOs and building reliable software and the right level of engineering with lower stress levels and more meaningfulness. And it does just take getting started and a will to do it. And it's actually, surprisingly, there's a very simple thing, one weird trick to getting technical debt under control. It's you slow down features. Technical debt only comes from features. If you can slow that down and get it to a reasonable pulse, you can build a sustainable engineering system that still delivers a ton of value, but it takes the reasonable goals. It takes getting started. You can't improve what you can't measure. And it takes having this will, right, the fortitude to say, you know what, we got to do the right thing here, and we got to make a hard call and a hard trade-off, but we're going to do it for the right reasons. And then as soon as that's up to a good enough point, you get back to features, because of course that's all that really matters at the end of the day. But you're going to generate more technical debt, and it goes on from there. So I don't know if those wishes are, I think I snuck a third wish in there, but anyway, those are my wishes.
I'll take 3. So
right.
That's okay. How would people continue the conversation? How would they find out about you and your firm?
I think I'm pretty easy to find. I'm on LinkedIn and on the social medias, Twitter at Kit Merker, kit@nobl9.com if you want to email me. Definitely SlowConf is something we want to get more people involved in. We do it as an annual event. We just launched SlowConf monthly. We have a 900 person community from a meetup, SlowConf monthly. And we just this week had a Clarion F1 race data engineer talk about how they take the McLaren data. We made sure no Ferrari fans came. And it was a fascinating talk where he took about the data that they collect from the F1 cars and related it to reliability engineering concepts and software. Very, very cool stuff. So anyway, SlowConf is a great place to get involved. Nobl9.com, obviously. And I'm on Twitter. I'm easy to find.
As you probably know, at this point, I open up the platform for you to promote anything you'd like. So you've educated me. You've educated the listeners of the Software Process and Measurement Cast. The platform's yours.
Well, so Nobl9, I'll just tell you what I do for a living, because maybe that's the best way to do it. You know, I've been in the software game for a super long time. I've worked on lots of different teams, building software, selling software, marketing to developers, working in open source, just so many different things. And this common thread of these hard decisions around the trade-offs, technical debt, et cetera, this has been the common thread for me, thinking about developer productivity and how to ship software faster. And so what Nobl9 is, we're an SLO platform. This is what we do. We focus on SLOs, error budgets, and technical debt, making it so that teams can get on the same page. The things that I think really separate us is, one, you can use whatever data you already have from like tons of different systems, Datadog, New Relic, Splunk, AppDynamics, Thousand Eyes, et cetera, all those systems. You can build service level objectives from all those systems. We do SLOs as code, which is a cool thing. You check in your SLOs using a declarative YAML. We actually have an open source version of it called OpenSLO, which we built with Dynatrace and GitLab. And the idea is you check it into source and use slowctl, just like kubectl, to apply the SLOs and to validate them. And so that makes lets you shift your SLOs into the code itself. It's permanent record. It follows infrastructure as code, GitOps principles. So SLOs as code is a killer feature. And then error budget based alerting. So not waiting until the SLO has already been violated, but instead saying, hey, you're burning error budget. And that is indicating that the service doesn't work. And you can look at that at two levels. One level is operational, where, hey, it doesn't work the way it's expected today. And the second is technical debt. So think about how you would budget a service for the technical debt you deferred, and then have it alert you that you may need to pay attention to that. And when teams can then insert it into their agile planning process, right? Hey, look, you need to make sure you address this technical debt in the next sprint, or at least have a discussion about it along with your backlog. That alerting can go into things like Teams, Slack, Discord. So it could be kind of an FYI. We can file JIRAs for you, obviously. We can kick off PagerDuty, OpsGenie, or ServiceNow for workflows. And we have a custom webhook. So you can do SLO-based auto-scaling or rollback or feature flagging scenarios, all based on that. So it's really easy to get started with it. And you can define SLOs quickly, get started, and then start rolling out changes to it, get that feedback loop going, get it all in one place. And it's not just a dashboard. It has a nice dashboard, but we actually let you export the data because there is no single pane of glass. We shatter the single pane of glass. You want to see it where you want to see it. So anyway, that's the pitch. Go check it out, nobl9.com/sign up.
Kit, this has been absolutely fantastic. You've gotten me fired up. So
well, thank you so much.
And Reread Saturday News. This week, we reread Chapter 6 of Project to Product by Mick Kirsten. In the chapter, the author tells 4 stories about disruption. They are interesting in their own right. Still, if we look for a common thread, I would suggest the communication needed to manage the balance between flow items, features, defects, risks, and debts. Check out this week's reread of Chapter 6 and previous chapters, links all in the show notes. In the next Software Process and Measurement Cast, we feature our essay on the role of the team lead in Scrum. As Mellisa Greller points out, the role of the TL is often overlooked. When a role is overlooked, it causes friction. And unless you are building a campfire, friction is not a good idea. We'll also have a visit from John M. Quigley. If process improvement is a never-ending journey, why do so many people ask, are we there yet?